Sorry about that, everyone. Again, this is one of the struggles of working from home. You can't control the outside situation, so I apologize, but now just continuing, and we're just about finished. A lot of good information on this chart. Like we said, so there are definitely some good homework questions and the how many question to make sure that we're aware of how to answer that. So we're seeing a little bit of arithmetic, not too much, but just getting some practice with our calculator, doing things like that. But the rest of today's class is just a few cautions, okay? Kind of mentioned one of these earlier, that we are very visual people in general. So sometimes people do this accidentally, but sometimes people do this very much intentionally, that they try and take advantage of these perceptual distortions. So here, they're trying to show you this little figure about the decreasing value of the dollar. So in 1980, a dollar was literally worth $1. But now, because of inflation, now we're looking at 1990, 10 years later, that same dollar kind of has the buying power, the equivalent buying power of 63 cents back in 1980. And now in 2010, that dollar only has a value of 39 cents. So what they're trying to do, we could definitely do some sort of a time series chart to just, show the value, to put our dates, and to have 1980, 1990. They didn't give us a value for 2000, but we do have one for 2010. And to have $1 here, that's where it started. In 1990, it was about 63 cents. So this would be 50 cents, so 63 would be about here. And in 2010, we're down to 39 cents. So we could have a time series chart, but it's very common to see things like this. This would give an accurate way to present the information, but by giving us this kind of a visual, it's trying to visually show the shrinking power of the dollar. But the thing is, our eyes, as they talk about, they're trying to do it by shrinking the length. So they're looking at this length compared to this length. Well, this length is 63% of this length. And then this length is 39% of this length. But by shrinking the entire dollar, we don't see one dimension. We see the two dimensions. So we don't just see this shrunk to this, shrunk to this. We're seeing the combination. We're also seeing this shrunk to this, shrunk to this. And overall, proportionally, this should be 39% of what we started. It's 39 cents. It used to be valued at $1. So this should be about 39% the size. And that length is, but in general, this little dollar takes up this tiny fraction. I guess maybe it would be a slightly bigger. But it looks like that dollar would take up about that fraction of the bill. That doesn't look like 39%. That looks like a much, much, much smaller proportion. So that's where a lot of these, they say it at the very, very end, the idea of pictographs. I remember a different textbook, I thought this was a good example. They were trying to talk about oil consumption, and it was where the United States gets its oil. And it made this chart, and it looked at oil. Again, this is all oil used in the U.S., the origin, where it came from. And they had a little chart comparing the United States to the OPEC nations. And they drew, instead of using a bar and having a good scale, they drew an oil drum. And then for OPEC, they drew this really fat, wide oil drum. But the point was that it was just looking at the height. It really should have just been a bar graph. And just like we said in class, we make our bars the same size. The point of the bar graph is how high the bar goes up. It has nothing to do with the fatness of it. So we don't want to mislead people by making one bar fat while a different bar is skinny. It's all about the height. That's the same thing here with these barrels. I should finish my barrels. That's the same thing here with these barrels. The point is, in the actual display, I think this barrel was just a tiny bit higher than this one was, and they actually had a measurement the millions of gallons of oil that were used, but it was such a close value. But by making this a big fat oil drum, they're trying to make it seem like we're so much more dependent, that so much more is coming from here. But in reality, it was a very, very close margin. So this idea of using pictographs, using pictures, most of the time, there's some misuse there, and that it's misleading people, sometimes in a way you didn't quite intend, but very often it is an intention. There is some intention. Here, this is very, very similar to the science tests that we were talking about, and I'll pull that out in just a minute to remind you. But if we're looking at this, and this graph was looking at women as a percentage of all college students. And if we're reading this appropriately, it's another time series chart. In 1910, 40% of college students were women. In this would be 1920. It looks like we're more at 47, 48%. Then 1930, about 42%. 1940, we're back to 40%. 1950, we're at about 31%. And then we see some rising patterns. So there is some good information here. But again, the sense of proportion, the fact that this did not start at 0, this is the better graph. This one gives us the better sense to see the trend. Starting at 40%, we had more women, a higher percentage of college students were women, then it dropped off a little bit, and now it's pretty much been on a consistent rise. And we've had more than 50% of our college students have been women since about 1980. That is an appropriate graph. There's no trickery here. We could see the good percentage values. Again, this would be another one. It wouldn't have hurt if they put the actual percentage above the dots, but we had a good sense by roughly lining it up to say what that percentage actually is. So why would someone do this? They may be doing it to try and exaggerate the differences, to make it seem like, oh my goodness, look at this. Women were going to college at big numbers in 1920, and they completely fell off the map. This almost looks like a lot of people at a quick glance, they almost feel like that's close to 0, because that's the way a chart should be made. So it almost feels like, look at this high percentage of women who were going to college in 1920 to almost 0 going in 1950. But no, it's still over 30%. That's a big drop. But that's what we see here. Just under 50% to here, just over 30%. That is the appropriate view of that drop, not this. And then similarly, it looks like we had almost no women going to college, and now we've got a massive total going to college. That is the better way to reflect that. So again, patterns. Our eyes look for visual patterns and trends. They look for something like this dot is more than twice as high as this dot. So now they start to think things like women, the percentage of women who are our college students have doubled from 1940 to 1980. But it hasn't doubled. It's gone from 40% to 50%. That's not double, that's an increase of 10%. But visually, you could easily make that mistake because of the sense of scale and proportion here. So again, that's where we could see these ways that literally sometimes little mistake, innocent mistake, people are trying to show something, but it gets exaggerated because they're not using a good, consistent scale. So that's it, everybody. I've got the homework problems included in the email, and they're posted on Blackboard. They're also included in the homework in the page packet that I have here. And let's see, next week, of course, we don't have class on Monday, just to get that reminder one more time. Next week, we'll make a video. I believe next week we'll just go into 5E, so that way when I see you in class the Monday after that, we can do a nice review and then start moving on and continue. So that's it, everybody. As usual, let me know if you have any questions or problems, and I won't see you until 2 Mondays, but that you'll hear from me again next week.